This is what winter solstice sunrise looks like at our place. Winter has officially arrived. This annual late December event also coincides with the appearance of one of the most interesting deep space objects, M42, the Great Orion Nebula. Centered in the constellation Orion, this dramatic object rises over the east horizon 2 hours after sunset. M42 is a stellar nursery. Turn your binoculars on this cosmic cloud and you will be witnessing the birth of stars. To observe M42, locate the constellation Orion. Orion is visible from December to February for most regions of Earth. The constellation gets its name from the ancient Greeks, Orion the Hunter. The most easily recognized feature of the constellation are these three bright stars. Orion's belt. Once you have located Orion's belt, you will notice this row of fainter stars hanging below the belt. This group of stars represents Orion's sword. These stars also locate M42. Study the area with a pair of binoculars and you will notice that the center stars are hazy, poorly defined. You are actually seeing the glow of the Great Orion Nebula. A small telescope will expose more detail. Images from large telescopes like the Hubble reveal even more detail. This huge nebula, M42, is illuminated by hundreds of embryonic stars, newly formed from the vast clouds of dust and hydrogen. Stars are created from the particles that make up the cloud of a nebula like M42. Astronomers call a star-forming nebula like this a molecular cloud. The force that starts the process of star formation is gravity. Isaac Newton's law of universal gravitation explains the process. His elegant law states that two objects attract one another with a force proportional to the product of their masses, m1 times m2, divided by the square of the distance between them, r squared. This means that any two particles in a molecular cloud attract one another. This attraction creates gravitational potential energy. The particles start to move towards each other. Accelerating through space, they gain kinetic energy. Upon collision, this kinetic energy becomes heat energy. If the two particles now stay close together, this increased mass will attract even more particles. Over millions of years, this area of the cloud will become denser and more massive, precipitating a cascade of particles accelerating towards this growing mass. The collisions will cause the core of this region to heat even more, eventually reaching a critical temperature of 10 million degrees Kelvin. At this point, atomic particles fuse together, releasing a torrent of energy. This is nuclear fusion. A star is born. We have come a long way in our understanding of the forces driving our evolving universe, and it's exciting to think that we can find and observe an object like M42 and actually understand what is happening there. We have more astronomy-related videos and projects at our website, hylaroad.com, or visit our YouTube channel, Science Online.